Question number 4. A circle has a center at point B, 5, 1. Let me draw that. So here's the center, which has to be labeled B. And we have the coordinates 5, 1. The point A, -1, -2 lies on the circle. So it would be somewhere over here. -1, -2. On the circle, find the equation of this circle. Okay, we already have the center. So we're going to do x -5 whole square plus y -1 whole square. And now I need the radius and then I'll square it. So for radius, apply a distance formula on AB. It's going to be -1, +2, in fact, minus y2 minus y1. So it's it will be, sorry, if I'm starting with y, it's going to be y -2, so +2 whole squared, plus 5 -1, so 5 + 1 whole squared. So we have 9 + 36, that is square root of 45. This is the radius. And then when we square this, we get 45, so we write 45 over. That's part A, equation of the circle. Next, it says that the point C is such that AC is the diameter. Okay, if AC is the diameter, then C has to be somewhere over here. So C could be a point here. Okay, let's first find the coordinates of C. We're going to use movement. You can also use the midpoint formula here. Okay, I'm going to use movement. So I know that this is going how many units to the right? Starts from -1, ends at 5. So that's a 6 unit right. And then how many units up? Starts from -2, ends at 1. So that's 3 units up. Because you can subtract 1 minus -2, you get a 3. So I'll have to take 5, 1, 6 units right. So 5 + 6 is 11. Comma, now we'll have to take 1, 3 units up. So that's going to be 4. So these are going to be the coordinates of C. You can also use the midpoint formula on C and A. So you're going to do -1 plus x over 2. And the answer is 5. And -2 plus y over 2. The answer should be 1. Solve these for x and y, you'll get 11 and 4 is again. Okay. Now we have the coordinates of C. It says that there's another point D, which has coordinates 5, 16. Okay, so since the coordinates are 5, 16, this is very important because this is also 5. So if that's 5, 16, that has to be aligned with point B, vertically aligned with point B. So D would be somewhere on this line because its x is also 5. Okay, say that show that DC is tangent to the circle. So then let's say D would be somewhere over here. Okay. So that's going to be 5, 16 outside of the circle. Okay. And we have to show that this is the tangent to the circle. So how can we do that? Connect these 2 points. And if DC is the tangent, then this must be a right angle. And again, if DC is the tangent, then the slope of DC and the slope of BC should be negative reciprocal of each other, or in other words, their product should be -1. So find both of these slopes. If their product is -1, that means yes, these 2 lines are perpendicular to each other. And if they're perpendicular, that means that DC is the radius. DC is the radius. Because we know that the radius and tangent, they are perpendicular. Okay, so now let's quickly find gradient of BC. Comes out to be 4 - 1 upon 11 - 5. We have 3 here and 6 here. That's half. Now find gradient of DC. That's going to be 16 - 4 upon 5 minus 11. So that's 12 upon minus 6. So that's minus 2. Now half times minus 2 is equals to negative 1. So you write that BC and DC are perpendicular to each other. So DC is tangent. The other tangent from D to the circle touches at E. Okay. Now, if you draw another tangent from here, it will touch the circle somewhere over here. And again, that would be aligned with the point C. So the y coordinates of C and this new point E must be the same. So the y coordinate E would be 4 as well. Now we need the x coordinate of E. So I'm going to use movement again. To go from C to this, we go move from 11 to 5. So it's going to be how many units to the left? 6 units to the left. Okay. And now move this 6 units to the left as well. So 5 goes, 6 left. So that's -1. So this would be -1. So the coordinates of E are -1, 4.